take down. Calculate the number of electrons present in 1 mole of the following compounds. A. Methane. B. Benzene. C. H2SO4. D. NaOH. Okay. Calculate the number of electrons present in 1 mole of the following compounds. The compounds are methane, benzene, sulfuric acid, sodium hydroxide. Okay, right. Now let us proceed. CH4. Let us have the general concept about the number of electrons. Number of molecules is equal to N dash is equal to mole into Avogadro's number. Take down. Mole into Avogadro's number. Now first of all we have to calculate the number of molecules present in 1 mole of the given compound. Okay, so it is after all 1 mole of CH4. So N is equal to 1 mole, because we already know N dash means number of molecules. N means number of moles. N, capital N, is Avogadro's number. So we have now N is equal to 1 mole as given in the problem. And Avogadro's number we already know, 6.022 into 10 power 23, right? Now, so we are interested to calculate the number of electrons. So the number of electrons present in 1 mole of a compound is given by N A Z. Okay, simply call it NAS. It's not sodium. N A is atomicity. Atomicity. Z, atomic number. Atomic number. Got it? Now let us consider for number of electrons in 1 mole CH4. Let us calculate this. Is equal to, what is Avogadro's number? 6.022 into 10 power 22. Okay. And what is the atomicity of CH4? What is the atomicity of CH4? Totally 6, is it not? Totally 5. See, that is C and H4, and in see, if it is atomicity of CH4 means you can call it 5, but we are interested to calculate the atomicity of individual element and atomic number. So in that case you have to split like this: atomicity of C in CH4, how much? 1. Atomicity of H in CH4, how much? It is 4. Now number of electrons in C, how much? That is atomic number 6. Number of hydrogen in one hydrogen atom is equal to, which is nothing but the atomic number 1. So in that case you have to do like this, that is 6.022 into, open the bracket, now you have CH4 carbon, so 6 and how many electrons? How many? What is atomicity? 1. So 6 into 1 plus, okay. And then what about the hydrogen? Hydrogen atomicity is 4, and how many hydrogen electrons are there? Only 1 electron, so 6 into 4. Are you able to follow? So that is equal to 6.022 into 10 power 22, open the bracket, 6 plus 4, so totally 10 electrons. So 6.022 into 10 power 22 into 10, that is 6.022 into 10 power 6.022 into 10 power 23 is Avogadro's number, okay. So 6.022 into 10 power 24. So this is the number of electrons present in 1 mole of CH4. Do you understand? Okay. So what we have done, we have individually calculated the atomicity and count the number of electrons in each atom, multiply it, then add, okay. And it can also be called, for example, how many number of electrons, how many electrons are present in 1 mole of methane, means 10 Avogadro's number of electrons. So you can do like this also. It is not 10 Newton, 10 Avogadro's number, you can put Na if you want. So 10 Avogadro's number of electrons are present in 1 mole of methane. So do you understand this concept? Okay. So can you calculate similarly for H2SO4, C6H6, C6H6. So what we are going to do, we have got already the number of electrons, that is equal to Avogadro's number into atomicity of the constituent atoms into its respective atomic number, okay. So here you have got 2 types of atomic number. So one is N, atomicity of A, carbon, and atomic number of carbon, okay. So you can put plus. Similarly, atomicity of hydrogen into atomic number of hydrogen, okay. So likewise you have to proceed. So that is equal to, you can put NaZ. If it contains a 2 different, means if it is of one type, means this one. 2 different means that is N into A1 Z1 plus A2 Z2, likewise it goes, okay. So here C6H6, so N into atomicity of carbon is how much? 6 into atomic number of carbon is 6, so 6 into 6 plus, what about this? Atomicity of hydrogen is 6 and atomic mass, that is atomic number of hydrogen is 1, okay. So therefore N into 36 plus 6, that is 42 N Avogadro's number. So that is equal to 42 into 6.022 into 10 power 23. You can multiply it. Can you get me the calculator? So it is 42 into 6.022. (252), that is 253. So 253 into 10 power 23. It means 2.53 into 10 power 25 electrons are there. Okay, got it? Are you able to calculate this? Right. Next one. Can you proceed with sulfuric acid? Try that. So how many types of atoms are there? 3 types of atoms. So you can proceed like this. C, that is H2SO4. So number of electrons per mole is equal to N into A1 Z1 plus A2 Z2 plus A3 Z3. Got it? Now N into A1 is nothing but hydrogen. So atomicity of hydrogen, atomic number of hydrogen, plus atomicity of sulfur, atomic number of sulfur, plus how much? Atomicity of oxygen into atomic number of, tell me, oxygen, close the bracket. Now N into atomicity of hydrogen, how many hydrogen? 2. Atomic weight of number of hydrogen, 1. So 2 into 1 plus. Similarly, atomicity of sulfur, 1 into, what is the atomic number of sulfur?
32.
16. Okay, plus, and what about oxygen? Atomicity is 4 into, tell me, 8. Okay, right. Now N into 2 plus 16 plus 32. So that is 18 plus 2, 20 plus 30, 50. Am I right? Okay. 50 into Avogadro's number. That can be further expanded. So 50 into 6.022 into 10 power 23. So that is 5 2s are 10, 5 2s are 10, 5 6 are 30. So 1 2 3, 1 2 3. So 301. Is it not? So 301 into 10 power 23. That is 3.01 into 10 power 25. Correct? Okay. So this much amount of electrons are present in 1 mole of sulfuric acid. Are you able to understand this point? Is it clear? Right. So can anyone calculate the next one? Sodium hydroxide. Proceed. Atomic number is sodium 11. Atomic number of sodium is 11. Oxygen 8. Hydrogen 1. So based on that you can proceed. Try. How many? Right, tell me. So let us calculate the number of electrons in 1 mole of NaOH. So what is the formula? N into atomicity of sodium into atomic number of sodium, okay, plus atomicity of oxygen into atomic number of oxygen plus atomicity of hydrogen into atomic number of hydrogen. That's all. Okay, so that is equal to N into, open the bracket, what is the atomicity of sodium? 1, 11 plus, tell me, 1 into oxygen 8 plus hydrogen 1 into 1, correct? So that is equal to N into 11 plus 8 plus 2. So 21, 11, huh? I'm sorry, 1 into 1, 1. So 20. So 20 N. So that is equal to 20 into 6.022 into 10 power 23. So that is 0, 4, 4 and then 2 6 are 12. Okay, 0, 2 2s are 4, 1 2 0, 1 2 0, 4 4 0, correct? So into 10 power 23, so 3 digit, so 120, 120.4 into 4 into 10 power 23, so that is 1.20 into 10 power 25. So this much electrons are present in how much? 1 mole of sodium hydroxide. Okay, are you able to follow this? Right. Now the twist is, I have given just 1 mole, but if I give a weight, what will you do? For example, I am going to give you, take down, calculate the number of electrons, total number of electrons present in 20 grams of sodium hydroxide. You got this point? 20 grams of sodium hydroxide. Calculate the number of electrons present in number of electrons present in 20 gram of sodium hydroxide molecule, sodium hydroxide compound. So what we are supposed to do? First of all, we have to count the number of atoms here, okay, based on the number of molecules. Okay, so what we can do, that is, we have got the formula, number of molecules. First let us find out the number of molecules. So N, we can put N dash. So N dash is equal to number of molecules. So there is a formula for this. N dash is equal to N into Avogadro's number, where N is mole, number of moles. So here it is given as simply 20 gram. They are not given in mole. So what we are supposed to do? We have got already the formula, N is equal to weight by molecular weight. Based on that you can work out. So in that case, instead of N you can put W by M into Avogadro's number. So from this you can calculate the number of molecules of sodium hydroxide. What is the weight of sodium hydroxide? 20 gram. What is the molecular mass of sodium hydroxide? Because M is equal to molar mass, is it not, of sodium hydroxide in this case. So 40, is it not? NaOH means sodium 23, oxygen 16, hydrogen 1, so 40, correct? So 40 into, and then Avogadro's number 6.022 into 10 power 23. So 0, 0 and 2. So 3.011. So the number of molecules present in 20 gram of sodium hydroxide. Take down number of molecules, not electron. First we are calculating molecules. So number of molecules are present in 20 gram NaOH. Okay. So this is 3.011 into 10 power 23. This we have found out. And next what we are supposed to do? We have to proceed with atomicity and the individual atomicity and the individual electrons of particular atom. Is it not? So let us have the number of electrons in 20 gram. So in that case 20 gram sodium hydroxide. So you have 3.011 into 10 power 23. Already you have got into, open the bracket, that is atomicity of sodium into atomic number of sodium. Is it not? Plus atomicity of oxygen into atomic number of oxygen, plus atomicity of hydrogen into atomic number of hydrogen. Close the bracket. So that is equal to 3.011 into 10 power 23 into, open the bracket. Now sodium 1, and what is this atomic number? 11, plus what about this O? 1 into 16 plus 1 into 1. So 3.011 into 10 power 23 into, open the bracket, 11 plus 6, 16, how much? 27. So 28, correct? Okay. So 28 into,
16
oxygen 16. Sorry, oxygen 8 only. Atomic weight is 16, atomic number is 8. Okay. So how much? 11 plus 8 plus 1, 19, 20 once again. Okay, 11 plus 8, 18, 19 plus 1, 20. So twice this. It means again how much? 2, 2, 0 and then 0, 6 into 10 power 23, and you got 0, 2, 0, 0. Okay, 3 digit. So 60.6.22 into 10 power 24, correct? So that is the number of electrons in 20 gram of NaOH. Got it? Okay. Now, like what we have calculated the number of electrons from the given atomic weight or given weight or given mole of a particular substance, we can calculate the protons also. Suppose if I ask you what is the number of protons present in 20 gram of sodium hydroxide, how much? The same number. Why? Because number of protons is equal to number of electrons in an atom. Do you understand this? Please note down. This is applicable. Take that. So this is applicable for number of protons also. Suppose if I ask you how many neutrons, so in that case what we are supposed to do? Mass number, you should know the mass number. Okay, mass number minus atomic number is equal to neutron number. So we will have similar calculation. Let us consider the same sum. Okay, take down. Calculate the number of protons and the neutrons present in. Let us have this one, this sum. Find the, take down, I will give you another sum. Find the total number of protons present in 34 mg ammonia at STP. Okay. Now 34 milligram of ammonia. First of all, we should be able to calculate the number of molecules present in 34 milligram. So 34 milligram can be converted into 34 into 10 power minus 3 gram. Okay, and this is the weight. Now, as I already mentioned, first we have to calculate the number of molecules of ammonia. Ammonia is NH3, and how many, that is number, N dash is equal to weight by molecular weight into Avogadro's number. So this is the formula you have to adopt. So N dash, the number of molecules, weight, how much, 34 into 10 power minus 3 gram, divided by, and what is the weight of, that is molecular weight of ammonia. Ammonia is how much? This is, nitrogen is 17, hydrogen is, nitrogen is 14, hydrogen 3, so 17. So divided by 17. Okay, into Avogadro's number 6.022 into 10 power 23. So 2 times. So that is equal to, again 2 2s are 4, 0, 12.044 into 10 power, how much? 10 power minus 23, 10 power 23. So 10 power 20. So this is the number of moles present in 34 milligram of ammonia. First we have to calculate the mole, right? And let us proceed. So for this much of molecules, now we have found out the number of molecules. Okay, in each molecule you have 1 nitrogen and 3 hydrogen. And what is the number of, so you can multiply number of electrons is equal to N dash, this is the N dash, into, what is that, atomicity into atomic number, 1 1, plus atomicity of hydrogen into atomic number of hydrogen. So that is equal to 1.2044 into 10 power, and this is 21, into, open the bracket, nitrogen, how many nitrogen? Only 1 nitrogen, into how many electrons are there? 7 electrons are there, plus, and this one 3. So it means 10, 3 into 1, 10. Okay, so into 10 means 22. So what is the answer? That is, number of electrons present is equal to 1.2044 into 10 power, how much? 22. Got it? So this much electrons, but we are talked about proton, so it is equivalent. So you can put, instead of Ne, you can put Np. Got this point? So Np is equal to how much? 1.2044 into 10 power 22 protons. Are you able to follow? Right. Now let us proceed with the second sum, that is find the, take down total number of, and they have asked another question here, what is the total mass of proton? So for which you should know the mass of proton. Suppose if they ask mass of proton means this much amount of mass of proton means 1.2044 into 10 power 22 into the mass of proton. The mass of proton is given by, that is 1.6726 into 10 power minus 27. That is the mass of proton. Take down. So what is the, we can ask another question from here. The total mass of new protons present in how much milligram? 34 milligram. So 34 milligram NH3 at STP is equal to, now mass of proton is given as, take down, mass of proton is equal to 1.6726 into 10 power minus 27 kg. So we have got already 1.2044 into 10 power 22 number of protons into 1.6726 into 10 power minus 27 kg. Okay, so that is equal to 1.2044 into 1.6726. So 2.014 into 10 power, this is 22, this is minus 27, so minus 5, this much, and this is gram, this much gram, because we are given in gram only. So here we have converted this into 10 power minus 3 milligram, so it is given gram, this much gram. And if you want to convert this into kg means 2.014 into 10 power minus 5 into 10 power minus 3 kg. So that is equal to 2.014 into 10 power, 1 minute, after all this is in kg, okay, please note down, this is in kg, so this is already in kg only, okay, please correct it. So it is 10 power minus 5 kg, because this is given in kg and this is mere number, okay, right? So the final answer is this one, 2.014 into 10 power minus 5 kg. Okay, now let us talk about how to calculate the neutron in a given molecule. That is the second sum, I think. Find the total number, take down, find the total number. Next question, find the total number and the total mass of neutron. The total mass of neutron. Usually they will give some standard values like electron mass, proton mass, neutron mass as reference value. Otherwise you can refer to Klux table. So mass of neutron in 7 milligram carbon 14 isotope. You know isotope. Isotopes are the elements having same atomic number but different atomic mass. Okay. For example, carbon has two isotopes. One is C612, another is C614. So this is atomic number and this is mass number A. Okay. and that's why they are called isotopes. Now we are talking about C14 isotope. Okay, now how we can proceed? Now listen, carbon 14, write the element carbon 14. Okay, and here what is the atomic number of carbon? 6. So this is A, this is Z. See, neutron number is A minus Z, neutron. When you subtract atomic number from mass number, you will get the number of neutrons. Okay, so the number of neutron, this is not Avogadro's number, this is neutron. Okay, so the number of neutron, or if you want to put, you can put like this. So the number of neutrons is equal to how much? That is 14 minus 6, that is equal to 8. Right, now we have to account for this 7 milligram. We know already number of atoms, okay, because it is given as atom, carbon atom only. So we have to take n double dash is equal to W by weight by atomic weight into what? Avogadro's number. So this is the equation you have to follow. Okay, now let us calculate n double dash, that is number of atoms. Number of atoms of C14 is given as weight, how much? 7 milligram. It should be converted as 7 into 10 power minus 3 gram. So 7 into 10 power minus 3 gram, and then number of atoms is equal to weight divided by atomic weight. What is atomic weight? Atomic weight here it is 14. It is not 12 because C14 isotope. So you have to divide by 14 into Avogadro's number, that is 6.022 into 10 power 22. So this is 2 times, and this can be cancelled, 3.011. So the answer is number of atoms of C14 is equal to how much? 3.011 into 10 power, this is 22, this is minus 3, so 19. Okay, and what else we are supposed to do? We have to count the what? Neutrons, that we already found out. For one atom we have 8 neutrons, so into 8. So number of neutrons in C14 is equal to, this is the number of atoms, so 3.011 into 10 power 19 into, and then for each carbon atom we have 8 neutrons, which is nothing but A minus Z. Okay, so that is equal to 8, 8, 0, 24. Okay, so 24.088 into 10 power 19. So that is 2.4088 into 10 power 20 number of neutrons. Okay, right? Two point 2.4088 into 10 power 20 or 21. Am I right?
Sir, it was number 23, sir.
23 in Botana. 22. 20 na?
20.
Get 222 na angiyum pottan by mistake. 3.0001 inge evlo varum? 23 inge 20 varum. 20 inge 20 appo 20 indha 21. Okay, so 2.4088 into 10 power 21, right? The brain sometimes it will cheat us. 6.022 போட்டுட்டு அங்க போட்டுருவோம். தெரிஞ்சா கூட அங்கே தான் ஷேடோ கிரே ஏரியா. So 2.4088 into 10 power 21 number of neutrons. இப்போ what we are further supposed to do, we had to find out the mass of proton. நான் ஏற்கனவே சொல்லியிருக்கேன் neutron. Take down the mass of neutron is 1.675. Let us proceed further. Mass of one neutron is equal to 1.675. Usually these values will be given to you. So 10 power minus 27 kg in the question paper itself. And what is our finding? That is total mass. Total mass of neutrons present in how much? That is 7 milligram, 7 mg C14 isotope is equal to how much? 1.675 into 10 power minus 27 kg into, and number of neutrons 2.4088 into 10 power 21. So shall we calculate? 10 power 21 into 10 power 27 minus 27, 10 power minus 6 kg, and this much is, we have 1.675 into 2.4088. So 4.035. So this is the total mass of neutron. Okay.